Okay, friends, this is where we left off. I don't think I got any questions, did I? Or did I answer them? Yesterday's a blur. Granted, yesterday wasn't a lesson day, so I think we're covered. And I mean this sincerely, if I'm dropping the ball somewhere, if you feel like I've forgotten something, haven't responded to something, please let me know. Because yeah, I feel like I'm some days just having trouble plugging into the part of my brain that works. Here's something. It's called Kirchhoff's laws, and I can tell you this is one of my funnest things. One of the funnest things for me to teach and just to do each year in grade 11 physics. So write that down. Good. Kirchhoff's laws. Good. Is this all going to fit on? I don't have my stack of CDs like at home. I'll move it up in a second. Because there's something down there that you can't see. The voltage law, what it says here, this is the series circuit right here, below, because you got all that written down, right? If you haven't, you'll pause it and take it down. This is in series. This is in parallel. What that means, and you'll see more of this, but in a series, if you have a circuit, it's like, so this is the source, and then you'll have V1 here, excuse me, V2 here, V3 here. It's all in series. Okay? In parallel, it's different. Parallel is generally a kind of combination of series and parallel, because you'll have like these bad boys in it. So you'll have, let's say this is V1, then you'll have V2, V3, V4, and then over here will be V5. If you're just like, what in the world? It'll make sense when we're doing examples. I wonder if we might run through an example before we do well, I'll show you something in a second. Anyways, so you got all that down. Now these formulas, V series and V parallel, these would be given to you on a test. So you don't have to memorize them. The more you work with them, you do all the questions stuff, they'll stick in your brain anyway. But you don't have to memorize these. All right? Okay, so that's the voltage law. This is the current law. This one, because the other one's old, this is an electric current. Okay, so this is with amps. The other one's with volts. This one's with amps. You're not going to be asked to regurgitate definitions. It takes time to do the problems that these things are involved in, so don't sweat this. It's information. Now, series and parallel for amps, for I, are opposite to series and parallel for volts. Okay, volt in a series plus plus plus, volt in parallel equals equals equals. Okay, cool. Once you have all that down, do the practice. We're going to do that together. Okay, we got that all? Yeah. I'm going to pause just so I can not bore you with me setting up the book. I want to show you something. Got it? Good. That's a lot of homework. I'm showing the cursor on the screen like this. 2 questions. Okay, when I said, consider memorizing table 1 on page 520, this is it. Just so you have an idea when you get these kinds of questions, for the very few of you that are going to actually write a test for this and aren't going to be in control of your material. So you know if you see these things, kind of what it means, and to not kind of worry or anything. So that's the table 1 that I was talking about. The tutorial that is worth looking at, if I can show it with this camera. So this is the tutorial is page 521. Yeah, you know what? I'm not going to walk you through this. But this is just kind of showing. So these two things here, they're in a series connection. These two are in parallel. Big picture, these two together are in series with these ones. Okay? You'll see, I'll really try and go slow when I do the questions. Talks about the flow here. Do have a look at these. You know, it might be an idea to kind of pause right now and just to kind of read through this stuff. All right? And then what I'm going to do is this practice for you. I'm going to pause it again just so I can set stuff up properly. But we're going to do this practice. Notice the formulas are right here. And then you do 1 and 2. Like I said, it's a short assignment. Look how tiny that is. But oh, so fun. All right, pause time. Okay, first of all, was I recording the whole time? If I was, sorry. I'm going to have to go look back at that because lots of times I talk to myself. And anyways, let's look at this. Isn't this beautiful? This is the most beautiful thing I've ever drawn in my life. And I'm a pretty beautiful drawer. So you guys have seen that. So if you need to pause and just, you know, I was going to say gasp upon the glory. You can do that. Or bask. Or, you know, whatever you want to do. You do you. As long as it's not illegal, immoral, or unhealthy. Okay, so this is practice on page 522. I've drawn a reasonably hand-drawn facsimile. Put my volts in green. Put my amps in red so we can kind of keep them separate. Now, the thing is, what we have to do, and I'll do my best to kind of go slow here, not skip anything, is we're going to be given certain values for some of these things. Question 1 has to do with volts, I think. Yeah, question 1 has to do with volts, and then question 2 is amps. So what we're going to do is we're going to be given some values for question 1. We're going to fill those in, and then we have to solve for the other ones. Okay? And right now, this will change, but right now, amps and volts are independent. We're going to add resistance to each of these, and those 3 have a relationship, but that's not yet. So volts, what are we given? V source is 60, so this equals 60. And with a marker, I hope I don't screw up. Source is 60. V1 equals 20. I'm not putting units or sig figs or anything right now, just to kind of keep this space clear. V1 is 20. V3 is 15. Notice that's also how I wrote them, so I could have room. That's why these guys are off a bit, so I got room to write this stuff. I've done this before. V3 is 15. That's it. That's all they're telling us. So now, what we have to remember from the formulas, just look at the V's here. In series, you add them and they equal the source. In parallel, they're all equal. So in parallel, I'm going to do that first. In parallel, they're all equal. V3 equals 15. That means V4 equals 15 and V5 equals 15. We had to figure out these two and this one. And we got to figure out this one. I needed to do these before I could do this. Because 15, you kind of treat them as one when you're looking at series. 15 and 20 is 35. 35 plus what equals 60? I'm going to go through this again. These two will add up, and let's say this wasn't parallel. Let's just say it went like this. Okay, series like that. This plus this would equal this. We are told what this total is, the V source is. So it's going to be this plus this. These are treated as one once you have them all figured out. So we need to figure these ones out first. Although really, it's kind of, once you do these for a bit, it's instantaneous. It's not figuring. It's like, oh, that's 15, 15, 15. Trickier with the eyes. But when you're working on the equal parts, then that makes it easier. This is the harder part, kind of figuring out that relationship. So we know these are 15. 15 and 20 is 35. 35 plus something has to equal 60. So it has to be 25. Now when it's asking for these answers, notice it's 2 sig figs. So when you have these answers, make sure you put the appropriate amount of sig figs and the units beside them. On a test, what I have normally done is I've kind of had this kind of space, and then at the bottom I'll put V1 equals, V2 equals, V3 equals, just so it's really clear, because then we've got our sig figs and our units super clear. So those of you that are kind of doing your own work, test, slideshow, what have you, make sure you show that. All right, let's move along to amps. Now remember, these have the opposite relationship as far as the formula goes. In series, they all equal each other, which means these two are going to equal each other, and they're going to equal this. But these ones, when they're parallel, they add up, and they will add up to whatever these equal. Okay? Hope that's making sense. So let's fill in what we know. Okay, so it doesn't tell us the source, but it says I1 is 0.7. I1, so this equals 0.7. I3 is 0.1. And I5 is 0.2. That's it. Okay, so remember, these are equal. These are all considered to be in series. These ones have to add up to what? To this. Circle the ones that I've given answers for. So remember, in series, they're all equal. In parallel, they add up. They add up to whatever's going on in the series. And the series is 0.7. 0.1 and 0.2 is 0.3. 0.3 plus what equals 0.7? This one will be 0.4. These all are 2 sig figs. So add our sig figs and our units. And that's how you do it. I think this is one of those things that's like, I could be wrong, but it's like you look at it and you go, what? I don't, what? And then, oh, and then it happens. It gets a fair amount trickier once we get resistance in here, because there's, I don't remember the formula, but like R equals V over I or something like that. Or I equals RV. Can't remember. So you have to kind of do all your stuff and then make sure each trio jives. Right now we don't. You can just do these independent of each other. Please, 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 if you're stuck, if it's not making sense, please look through tutorial 1, page 521. Please don't kind of zoop through all of this and then I'm stuck on 1A. Okay? Look through the tutorial and then, but you know, if you need help, not because you're lazy jumping to it. And I'm not saying this because people have been. I think people have been really good. I don't think people have been kind of skipping steps or anything like that. But I just want you to do your due diligence and develop those good learning habits. So now, before I post this, I'm going to make sure I didn't record myself being dumb. Unintentionally for a change. Okay, bye.